Using our inverses that we just found, we are going to throw in domain and range. And if we look at our original, 2x plus 3, well, that's a line, so if you don't know, you can always think of it as a linear equation. Domain is going to be negative infinity to infinity, and range is also going to be negative infinity to infinity. We don't have any square roots, and we don't have any fractions to worry about exclusions to those two. Easiest way to find domain and range of your inverse, well, we could go through and take it again from this new function. Once again, it's still a line, so it's going to be all reals. But if you look at what we actually did, so to find the inverse, we flipped x and y, and we solved it for y. So what was dealing with x's, my domain, is now dealing with y's. That's my range. What was dealing with my y values, the old range, is now dealing with x's, or the new domain. That's the easiest way to go about finding domain and range of an inverse. If we use our second example, x squared minus 1, our domain is not negative infinity to infinity like it would be because we have this exclusion. My domain is going to start at 0 and it's going to go to infinity. The range, once again, is going to start at 0 and go to infinity. So then if we're looking at domain and range, now this isn't a great example because when we flip them it's going to be the same. But what was dealing with x's now deals with y's. So my range of the inverse is 0 to infinity. What was dealing with y's, the original range, is now going to be the domain of the inverse. So domain and range are always going to be the opposite of what they were when you have an inverse function.